brief one background slide on me. I've been messing with computers since 1985. Spoke at DerbyCon last year, had a great time, wanted to come back this year. I'm from up around Dayton, Ohio, so I just drove down this morning. Really kind of neat to have one of these in my backyard instead of having to fly to Vegas. The day job, I've been a contract sysadmin since 2004, jack of all trades, Windows, Linux, networking stuff, you name it. And then I've been subcontracting for a few years for an IT security firm, doing internal, external network and app pen tests, doing some architecture reviews, red team, blue team exercises, fun stuff like that. So just to dive straight into the subject matter, why dynamic access control? Why did they put this in the product? What's this going to do for us? DAC is basically to overcome the inflexible, inefficient NT-ACL model. And this is an ACL model that dates all the way back to NT3.1. This has been how NT has always worked. And it's based on a Boolean OR operation. If you look at it at the ACEs in an ACL, you're a member of this group, you get this permission. Or you're a member of this group, you get this permission. And everything's evaluated with an OR. Now the permissions, they get binary ANDed together. Deny is treated a little funny. But basically, because of this OR model, you end up in a situation if you have geographically distributed assets, if you have multiple departments, if you have multiple projects, if you have multiple axes that you want to grant permission on, you end up with this multiplicative effect where you're saying, I need a group for the Chicago Engineering Project A, Chicago Sales Project A, Milwaukee Sales Project A. And you start making these multiplications of groups, and suddenly you get group bloat. You've got a whole bunch of groups in your Active Directory because you need all these groups in order to model the permissions that the business is saying they actually need on the resources. The other side of that coin is you end up with token bloat on your users. So if a user is a member of a large number of groups because of the various cross-functional, whatever they do in the organization, you end up with a large security token. And just architecturally in Windows, the more bytes are in the user's security tokens in aggregate that are being processed by a file server, the less users that server computer is going to be able to handle, the more data you're throwing around over the wire. It's very inefficient. So group sprawl and token bloat, not good things. DAC makes attributes in AD usable for security. And attributes in AD weren't usable for security before. So for example, you get a department attribute in a user account. You fill in the department attribute, that's great, it does nothing for you. You can't name it in an ACL and have anything actually happen. Well, DAC actually makes those live, makes those sources of security decisions. Now, there are concerns about that we'll talk about on a later slide, but it takes this practice that I hear colloquially referred to as shadow groups is something that DAC is going to let you do away with, and that's, for example, everybody in the sales department. Yeah, they've got department sales in their AD object, but you've got to go make a group and put them all in it. Well, now you're not going to need to do that anymore. So you're not going to have groups coming out of sync with what the attributes in the AD say because the attribute in the AD is authoritative. And then kind of a little window dressing feature, but I'd bring it up because it's in DAC. You can give users access denied remediation messages. So if the user gets an access denied, you can actually control what they see. Like they can get a message that says, hey, you need to go to such and such web page or email so and so for access to this. So I think that's kind of cutesy, but hey, it's in there. It's kind of neat. If I boil all the rest of this down into one slide, so you can see the slide and you can get up and leave and go to somebody. The DAC takes users, client computers, and resources, and it describes them by attributes. It lets you use those attributes in expressions with Boolean and logical operators to make permission decisions. So that's all that DAC, boil it all down to one slide, put attributes on things, make decisions based on what attributes are on those things. So previously, security groups, that was it, and users and individual principals, but security principals, that was it. This opens the world up in terms of everything in AD can be used as a security arbitrator. So what are the pieces and parts? DAC composed three basic sets of pieces here. The first are claims. This is taking AD attributes of users or devices and pushing them out to file server computers so they can make the decisions. So a user's department attribute, which is the department's the classic one that gets used in all the examples, that attribute can be made into a department claim. You're defining this in the AD administration tools on a Windows Server 2012 or Windows 8 client. And you're going to take AD attributes and say, yeah, I want this to be a type of Boolean or SID or integer or whatever the appropriate type is for the AD attribute, and make it available to server computers to use in decisions. Oh dear, I have slides out of order here. Okay, so we'll skip back. Okay, components of DAC 2. I'll skip back to that slide. I don't know what I did there. Clearly I slept since then. Second set of components of DAC are the classifications of resources. So nothing like this existed in the product before. This gives you the ability to flag files and folders as to attributes of the resource itself. Are these PII? Are these HR documents? Is this share all HIPAA compliant documents? So some kind of toxic waste sludge that you want to tag it so that it can be dealt with specially. So resource classification, there was nothing like that in the product before. The resource classification themselves are stored as alternative data streams in the NTFS. I don't know, if you guys remember alternative data streams, if you know what they are. It's a neat little feature whereby, and it's been in NTFS since way back, probably the first version actually, where a named stream of data can be stored along with a file. So you think of the file having its contents, that's its main stream. Additional streams of data can be stored right along with that file, right beside it in the file system, that they sort of appear opaque, and I think a lot of people are afraid of them because they think of malicious storage of information, hiding data behind the scenes. I have a copy of Notepad that actually has malware in an alternative data stream or something like that. And yeah, it can be used for evil, certainly, but it can also be used for storing legitimate metadata about files, and that's what DAC does, is the resource classification is stored in these alternative data streams. Quick little aside on like Battle in Windows 2012 features here. So if you're familiar with REFS, Reliable File System, that's a new file system that was added in Server 2012 that's journaled metadata and journaled data. So NTFS is journaled metadata only. REFS is journaled metadata and journaled data. It's supposed to be more reliable. That's Reliable File System. And supposedly it's a subset of the NTFS features because the NTFS code scared the shit out of everybody who worked on it. They said that it was like this labyrinth of structured exception handling that was used for logic, not for exceptions, but like throw an exception to mean something in logic and just scary stuff like that. And nobody wanted to work on it. So REFS supposedly came out of that. But REFS doesn't support alternative data streams. So you can't tag resources on a shared REFS volume with any kind of resource classification because it can't store that. There's just no place for it to store that. So I thought that was interesting. That it looks to me like two battling features in the operating system. Office documents, properties. So this is, you're in a Word document, whatever, you do a file, properties, and you can add tags and various metadata to the document. That's actually stored within the document. That's not stored as an alternative data stream. So Office 2007 file formats, they're just zip files. The server just pulls them out. 2003 and older files are OLE compound documents. They're like file systems in a file, and it just reaches in and pulls them out. So that's how those get handled. And then the third piece here, finally, one of the conditional expressions. So I just threw an example screenshot here. This is a shot out of the actual admin tool. And I apologize, I'm kind of short on screenshots because I never am exactly sure what to take, and either I take screenshots of everything or I take screenshots of nothing. So this is a nothing presentation. So we're saying here that if the user's department is equal to, and then we have a list of values to choose from. And when you create claims, you can create enumerations of values so that instead of just being a free form type anything you want in field, the file server admins or the people who are creating your central access rules, we'll see later, actually have enumerations to choose from so they don't misspell things. Which, if it were misspelled, it wouldn't apply because it's a computer and they're, rock stupid. It's going to do exactly what you tell it to. So that's the components of DAC. What are the requirements necessary if you want to actually implement DAC in your network? You need Server 2012 DCs. You need at least one because only a Server 2012 DC can supply a client with the claims. You need a number of them sufficient to handle the load of your clients jumping on it. I couldn't really find good published numbers from Microsoft about how many clients to what the ratio needed to be. The file servers need to be Windows Server 2012. If they're not Server 2012, they don't understand claims, they won't do anything with it. So under clients, user claims can come from any operating system. Those two bullet points should probably be flipped because user claims are probably the first claims you're going to get involved with. Device claims, I don't know that I articulated properly. I probably should have had a better slide about it earlier, but device claims are making arbitration decisions based on attributes of the device. And I think there was never anything like this in the product before either, and I think this is really cool. You could say that these documents are only accessible from these devices. And in the past, the way that you did that was crazy shit like IPsec policies and firewalling and this file server that you had to be in a certain IP address space to get to it, and stupid stuff like that. So device claims let you restrict permission to subsets of devices. Really neat, requires Windows 8 clients. Maybe Windows 8.1 it'll be better, and then this won't be so unpalatable. But you can't get device claims from down-level operating systems. User claims do come from down-level operating systems, and I'll talk about how that works on a later slide. So claims are going to be the first thing that you create when you're putting DAC together, because these are what you're going to measure. Claims come from AD attributes, and you define what AD attributes you're going to use in claims. It's not the case where all your attributes in AD are just available as claims just automatically. You have to choose, because there are, depending on whether you have Exchange installed or not, depending on whether you have Link installed or not, there could be hundreds of attributes on a user object, and you don't want to be pushing those around if you're only actually measuring just a couple of them. So this claim creation process is the mechanism where you tell DAC, these are the attributes I care about, so the DCs push those attributes out in Kerberos tickets. You need to think about the source of these attributes, because they've never mattered before. Maybe a little bit with Exchange address lists, but that's about it. So now suddenly, the values that are in these attributes are going to be making decisions on permissions to access file resources. There's no validation of attributes done by AD, first of all. It's to whatever you put in an attribute, it's there. As long as it's, don't put a string in an integer. I mean, there's minimal validation. That's just because of data types. But, if you misspell something, if something goes into the wrong attribute, it's there, whatever. So Microsoft recommends you populate AD attributes as imports from authoritative curated sources, like your HR system or a provisioning system, FIM, or something like that. You're probably going to be moving security boundaries in your network when you do this. So what somebody typed in the job title field in your HR package never mattered before. Now suddenly it could control what documents somebody can get to. So suddenly you may need new controls around other pieces of software in your organization that it never mattered what went in there before. And now suddenly you've made HR people quasi-sysadmins. So think about how security boundaries are moving. And then think about any delegation of attribute modification that you did. If you gave users the right to modify their job title field, and job title field matters in a security decision, you just made them sysadmins over their job title and potentially file server access. So think about how this moves the security boundaries in your organization. Sticking on claims for a second, here's another practical screenshot slide. To see the claims applied to a user, and I don't have device in this. I actually didn't have a Windows 8 client in order to do device. I took this from a Windows Server 2012 screenshot, but the command is the same. Whoami/claims also shows the claims that are in their ticket, as well as their group memberships and their privileges. So that's a new in Windows 8 Server 2012 feature. So the second item then, resources. You've got your claims. What are you going to measure from the user device side? Resources, what are you going to measure on that side? A quick, plug here for the file classification infrastructure. This feature came up in Windows 2008 R2, and it really felt like one of those thrown in at the last second. So it had no GUI. You had to interact with it from a PowerShell API. It was basically the only way to interact with it. It ran as a scheduled task. Only administrators could deal with it. It really didn't look like it was ready to do anything. In Windows Server 2012, it runs in real time. It's got a GUI, and users can classify documents. So what this file classification API and infrastructure does is it allows the server to make decisions about what tags to put on resources automatically. It allows users to add tags. It exposes a PowerShell-based API. So if you want to write your own classification algorithm in PowerShell that you can say, based on a file name or based on the content file, anything you want to do, the day of the week, the temperature, whatever, if you can express it in PowerShell, you can cause the classifier to automatically classify new files as they're saved onto the server just in real time. There are third-party classifiers available. These things are somewhat spooky to me because I feel like it's building Skynet or trusting the computer with things we shouldn't. So there are Bayesian classifiers out there. I saw one that you feed it a corpus of documents and you tell it, these are engineering documents. You tell it, these are sales documents. And then it will do fuzzy analysis of files and tag them with tags based on what it's seen in the past. Little spooky, but that's out there. Taking the claims, taking the resources together, you use those to build your central access policy. This is actually the instructions, the marching orders that are going to go out to file servers to tell them what to do. Think of the central access policy as a lot like an NTFS DACL. It's a list of permissions, all packaged up together. It's stored in the AD in a special container. It's just schema that gets added when you do a W2K12 domain prep. This is not a domain functional level thing. It's just schema. You can do this. You can do DAC on a Windows 2003 domain functional level, and it'll work fine. It's just additional schema that's added into the AD. The file servers pull down this ACL from AD and store it in their registry, and then they refresh it periodically. And this is what the file servers use to then evaluate access attempts on resources. There's a neat feature in here called staging policy that I probably should have dedicated some slides to. I'm just going to quickly hit what that is. You can have two central access policies. You can have the current applied policy that file servers are actually using, and you can have a staging policy where you're trying out new modifications. Because if it were all production and you made a mistake, you could break access to resources big time. So staging policy allows you to have a policy that is not enforced. It is evaluated, and if the server finds that there's a difference, if the current running central access policy says allow and the staging policy says deny, an event log entry is created that then you can collect and report on. So you can make changes to a staging policy, put it out there into your organization, get into your event log aggregation, and see where is the staging policy screwing up, or where is it succeeding, where is it differing in behavior from my current running policy. And that's kind of neat. They put that functionality in there. It seems very un-Microsoft-like. I would think they'd more just throw you to the wolves, is how they've been on prior products. But they actually give you a way to test what you're going to do before you go live with it in your production environment without having to build a separate parallel infrastructure under glass. Central access policies are made up of central access rules. So central access rules, think of them as... they're another slide down. Think of central access rules as being analogous to the lines in an access control entry, an access control list, the ACEs. Central access rule says for a given type of resource, these permissions will be applied based on these conditions. So here, again, with my helpful screenshots, this central access rule called Canada targets all resources. Now, in that all resources there, I could have that targeting PII. I could have it targeting payroll documents. Whatever classifications I've made up could be in there. Then down at the bottom, the permissions, the current permissions, and I apologize, I cut off the principal column. I'm not good at screenshots. So in that red one that's highlighted at the bottom there, the one that's highlighted in red, I'm allowing modify rights for a security principal based on the user's C attribute, which is country, equal to the resources country, and the user's department equal to the resources department. So if I have, say, crazy European privacy restrictions, so I have some users that are in United States trying to access documents that are tagged with Belgium country. Sure, maybe the user is in the HR department and the document's tagged HR department, but the user is in a country equal to the United States, the document is in a country equal to Belgium, policy doesn't apply. So this is actually taking that conditional logic and making it apply to whether or not a permission is going to be granted. You can get really baroque with these because there's string you can do equal strings, not equal strings, member of group, not member of group, greater than, less than on integers. So you could do all kinds of crazy stuff in this. It's not Turing complete, but it's like a little functional expression language. So central access policies made up of central access rules. I'll briefly throw in here central audit policy. This is analogous to NTFS SACL. So these are auditing ACLs. So you can take all the richness of these expressions and apply them to auditing. So previously your auditing was like, typically I found that auditing in NT was a very blunt instrument. This allows you to make auditing a much less blunt instrument because you can have criteria on your auditing. And I'm really killing the time here, I can tell. So I've got a few more slides, but I'm going to breeze through these. DAC will work cross-forest. There is a transformation filtering mechanism so that claims from one forest could be trusted or not trusted coming into another forest. There's a really neat hack mechanism for down-level DCs with a Sentinel SID. I'm not going to go into how it works, but research it if you're interested. It's a cute little hack that lets a forest have a down-level DC at the edge but still process claims. This all works because of changes in Kerberos. So the claims of a device and a user are coming down in a Kerberos ticket in the pack portion of the ticket. To do device claims, so like I said, Windows 8 devices, you want to based on what the device is the user's using to grant access or deny access. That requires armored TGS requests. There's an RFC, I don't have it on this page. There's an RFC that describes armored TGS. It's on the next slide. And I'm not going to go into what it is. It allows for some resilience to offline dictionary attacks in the protocol, only supported in Windows Server 2008 and up. So you can't have any 2003 DCs, and only Windows 8 clients supported on the client side. There's compression in the tokens now to help out with them getting Gymungous. And compound authentication is what Microsoft is calling the mechanism that puts device and user claims into the same ticket. So if you see that, that's what that is. I've really killed it in time here. Sorry about that. So protocol differences, Windows 8 clients versus pre-Windows 8 clients. Windows 8 clients get their claims from the DC and pass them to a file server. Windows 7 clients, XP clients, they can't do that. So the file server will go get their claims for them. The file server is Windows 2012. It knows about claims. It'll do it. So that's the difference. An 8 client gives its claims to the server. A 7 client says to the server, hey, I'm such a client. The server goes and gets the claims from the DC. That's how it works with down-level clients. Compound authentication I mentioned already. Kerberos armoring, there's the RFC 6113. Prevents dictionary attacks against the AS rep packeting Kerberos. The last one, next to last slide, last slide picture. Problems DAC doesn't solve, and Microsoft has come out and said, hey, it doesn't solve these problems. We don't have a solution to this yet. Just like you can't tell where a security group's been used in your network, you can't tell where a DAC policy's been used. So if you create a DAC policy and you decide later, I want to change this, I want to delete this, you better use staging policy in order to see what the ramification is, because there's no reporting mechanism to tell you where they've been used. I would hope that they'll fix that down the road. Staging policy lets you see the business impact of a change before you make it, and that will help you in not blowing everything up when you decide you want to make changes to your DAC infrastructure. Whew. So I rushed through the last few slides. I think I'm only slightly late, so thanks everybody, and I'll be around, and my email address is there at the bottom, and that's what I got.